discuss something. Last guest lecture is by Jonathan, who discussed something about the data engineer in industry now. What we are trying to do is deliver today is our understanding about what a data engineer or the whole data platform will be in the coming century, probably 2 years or 3 years later, from our understanding, which we believe is knowledge graphs and GraphRAG. And that's probably will be the core for the next generation of the data platforms. So that's our topic today. And it's quite an honor to be here today. And I know it's the final of the semester, so everyone probably have the pressure. And I think after this, Jihan will give everyone an idea about what will be the final exams. So, okay, we will start. This is the structure we will go through today. So we will first discuss why we learn graph in the second half of the semester compared to in the first half of the semester, like we learn in the relational one. Why we are doing that. And we will discuss what's the challenging in the data engineering now, and what is knowledge graph, and what's the role here, and how it works. Then it is something probably will come into reality in the coming next few years. So first, some introduction. My name is Pascal Sun, and I used to be a full-stack developer. I pretty like this title. Like, there is a lot of different titles can be defined when you're in the industry. It can be like from the very beginning, it can be a software engineer, developer, or then you go into like a senior or medium level, and then you probably have the title team leader, or this kind of things. But I very like this title because first, I'm full stack. I do basically everything needed to get the job done. And then I kind of treat myself as a developer, even though I have done a lot of works from the front end to the back end to the database, even to the whole solution architecture. So, and then currently I was like a final year PhD candidate here in the European PRP group. In the past, I probably working in the industry for 5 years. I delivered 3 pretty successful products already commercially, and lead some AI product development. For now, my research area is unstructured data, processing, structuring, representation learning, and applications. So this is one of the products I have built. I'm not sure whether you guys drive the car. If you drive the car in the Perth, you probably see that small tubes on the road. That's a product from this company I worked on with. It's small tubes used to monitor the traffic on the road for the speed and the classification of the road. Of the car. So different city councils, all the state governments, they can use the data to decide whether they should put more money in this road or put more bumpers in this road if it's a distributed road within a suburb. So they can get you guys go into the big roads rather than the small roads because the neighborhood will complain about that. And when I was first joining the team, is you see the counters on the road, it's pretty manual process. And if the traffic engineer trying to see the data, they need to go probably 10 steps. They need to plug devices into the computer, load the data out, and then load the data in a specific designed Windows app. And then probably after half an hour, they can get a result in the numerical way, not in the chart way. And then they need a dedicated team doing the Excel and visualize it as a chart. So what we are doing is not really that innovative, but we're trying to build something supposed to be there, which is the traffic engineer can just directly drop a file of the traffic data, and the platform handle the rest. In the end, they will see something like this on the map, so they can understand which road have the high traffic, which road have the large, heavy vehicles. So they can do some road safety designs, behind the scenes. So they just care about what they will focus on. So this is basically when I first into the career, we built this from scratch. And for now, this one has been sold to probably 100 to 220 different countries, a lot of local council governments. And it's delivered quite a lot of values. But this is a very good example here I want to deliver is what we are doing today, when you finish this unit, is data engineer. Why are we doing data engineer? Because we put the data together as a big data. You still see a lot of insights to become useful, really beneficial for real-life applications. And in the same basis, we actually built some hardware also. This is like solar panel-based traffic counter. We're trying to already deploy it in the Kings Park Road and also the Mountain Bay Road. You probably can see several devices. And this one actually is like a evolved version of this, because every day this one is real-timely pushing the data to the cloud. So later when you're trying to go into the industry, you will have a specific streams of the research, or not research, dedicated team. What they are trying to do is, for example, in the mining companies, they have a lot of devices on the sites. Every day, every minute, every second, they have the data pushed to the cloud. And this data pushed to the cloud will get a lot of stress to the database. You need to be able to architect it and be able to streaming, gathering data right into the database carefully. And don't really get the performance to be done. So that's basically similar to what you have done in the project one, when you're trying to do the ETL to doing the loading data. But difference is this data is real time pushing to the cloud. You need to do the batch process. So that's one specific categorization of the job people was doing as a data engineer. And then I actually worked with AI startup. This is when the AI was started to shining up. Like in 2017, when people was trying to talking about AI, it's normally about the computer vision. And the computer vision, what you can do, this is like you go to the hospital, you do the CT scan for your heart. And then it's a 3D heart, so it's basically a lot of images stacked together. What you can do is with a deep learning model, the AlexNet was being proposed in the past 10 years. You can get that process in. You can determine whether these pixels on the image is heart vessels or not. If it is, then we can try to doing a reconstruction of the heart, which is this image here. So this is the heart vessels. And after this, what we have bring in the innovation here is before was when the radiologist and the cardiologist are trying to do the diagnosis for the patients with this cardiology disease. We get one shareholder says when he is 60 years old, he get go into the diagnosis and do a CT scan and waiting for the result. He waiting for 6 months until the result is back. Even it is kind of a good result, not bad result. But he basically live in the pain for 6 months. But with this AI and the whole platform we built to processing this data, we basically reduce the time down to 10 minutes. So basically you do the diagnosis in the background, the ETL pipelines you build, running the machine learning models and output it, push it to the front end, and then in 10 minutes you see the result. Even if AI proposed just a rough result. But radiologists can work from this one, trying to do some edit, and then send the final report out. If you need to do the treatment, then you can do the treatment the other day. So that's really what's the inspiring part about this kind of data-driven applications, really saving the lives in our real daily, every day. So hopefully later, if you guys finish in this semester and find a job, you can deliver some very high-value applications like this. And this is one of my hobby projects is the map. It's actually a criminal map for the person. So you can see the western area near the UWA is kind of relatively safe part, but for the other part is a bit risky. But this is also another idea to tell you when you put the data visualizing, showing it somewhere, it's pretty powerful. You can get some very intuitive understanding of it. So that's just about myself when I was doing the product. And today, what we will discuss about the first question is why we learn the graph in this unit. I'm sure anyone have, or you have seen about this question? Anyone have a challenge about whether we should learn this graph things? Anyone feel the second half semester is much easier than the first half? Yes or no? No? Don't think the second half is much easier than the first half? Okay. But I think probably you guys, if you haven't think about this question, then think about it now, why we learn the graph. So that's basically what we've done in this unit is in the first half of it, we're trying to do the data modeling, which is focusing on the relational database one. And the core idea in that part is about the StarNet and the star scheme. How could you get the data being transformed and put it into a starnet or in the dimension tables and the fact tables. Then you build a data cubes. And then afterwards, how could you efficiently answer your business queries with the design you have set? That's basically what we have done in the first half semester. But in the second half semester, like this year is a bit different from last year. Last year we basically used the same data source. We asked students trying to transform what you have built in the relational database into a graph database. So this basically gives you the idea about what is a property graph, what's a cipher, what's like a knowledge representation. And the core part of it, what we're trying to deliver is graph models compared to the relational models. It is very, very flexible. Nodes, edges, that's it. All of the other things are derived. You can have your own ownership to define any of it. And the powerful of it is like it can be transferred. So what's the key differences and the key what's the shared goal they have is they're trying to answer the similar or answer the business data problems from this different perspective with their own capability. For example, in the relational database, you use different tables. And I think some of you guys, when you submitted project 1, we subsequently asked you guys actually using the data cubes, because data cubes is a core side of this first half unit. It's getting your queries more efficient. However, there is still a lot of students trying to submit the project when you're doing the business queries. You haven't actually using your cubes. You just use the join, which is fair, but not that powerful when you handling a very large data set. But in the end of the day, when you're trying to really solve the problem, you will say, in the industry, you get your manager to come here to say, hey, give me the data about this question. The first thing you will do is not to design a data warehouse as what we have done. The first thing you will do is open your database, probably is a SQL database Data Studio. And then you're trying to run a SQL query using a join several tables together, and then you get a data out. And give it to your manager. The manager say, okay, this is probably not what I want. Or your manager will say, okay, this is what I want, however, that's not enough. From this data, I have more questions. So that's basically is a fundamental part of the relational database. All the startup things are, from the engineer perspective, how can we get this process be more efficient? However, it definitely has a problem, right? That's what we are going to talk later. And for the GraphDB part is, if you have a very complex data problem, like the Amazon, or probably more local example is like the WPs. If you're trying to locate the suspects, what you should do, you need to find the connections between different suspects or different people, and trying to locate who will be the suspect. So at this scenario, then GraphDB will be super powerful, and actually they do. In the West WPs, they actually have a graph database in building house. I think 2 years ago, we was giving them the advice, and they group a team and doing this kind of processing. So they kind of going this way pretty deep, and the result is for the subsequent user cases is already very good enough. For example, if they see if you drive on the road and they see your place, I'm not sure whether I can say this, but they already have that camera and target you, so they can use that plate number, go into the database, run a Cypher query, and gathering all the records you have with WPs out to understand whether you are a high-risk people or low-risk people. So the officer probably will call more people or less people to approach you. So that's kind of two different business problems, but they're kind of solving it by these two different data modeling from a different perspective. And what's the key differences between these two data models from the star to the graph? This is kind of a very, very simple illustration of the star net or star schema. So you have the dimension tables, you have fact tables, you have a central focus on the business values you're trying to deliver. And your relations are fixed, it's optimized for the analytic queries, and it's highly structured. If you want to change things later, you still can, but it's hard. And for the graph one is, our interest will changes every day. Someday you probably want to know what's the relationships between these two dimensions. How could you try that out? Then this star schema come to its following. It won't be able to answer the question So we need to represent their relations between different dimensions together. That's basically why we kind of moving from the star net schema to the graph representation for the relationships. And this is kind of a unified idea, like semi-idea architecture for the data. So basically you have structured data, you have semi-structured data, you have unstructured data, you have streaming data like the devices pushing. And most of them nowadays in the industry is like is definitely pushing to a relational database, no matter which kind of data it is. Even, for example, WordPress. WordPress, most all of the database tables, they don't really have a formula key with each other, but they still is stored in the MySQL relational database. So everything will come to the relational database. But if they want to do the specific things, specific user scenarios, they probably were doing the ETL specific process, like what you have done in the project 2, and push it to a graph storage. And some of the established application scenarios is this kind of 3 different things. For example, in the financial, they will use the GraphDB to understand all the transactions. And people do the money nary is the same thing, like how could you track the people who's doing the money nary? You need to track all of the input and output in different accounts. So if there is abnormal patterns, these people from Australia trying to send some money to the people from, let's say, like the South Atlantic, there's no people here, some people here, right? So that's pretty rare, and that's abnormal behavior. Then in the graph, it will be represented as a pretty rare patterns of the graph, like a structure. Then that can be detected, which will be very powerful. It's already been applied. And for the e-commerce, that's another scenario. GraphDB already been used. You actually doing it in the, I'm sure whether that's project 1. You're doing the association rule pattern mining. But I think there is a very outstanding like examples in the Amazon like website. Is like they're trying to predict if you buy the product A and product B, you have highly likelihood to buy the product C. So they give you the recommendation to push you to buy that. Then this is actually also, they changed that because if you do this association rule pattern mining, that's pretty inefficient and it's kind of limited. So they actually have the whole transaction being built as Amazon product graph. And then on top of that, they're trying to apply some they developed graph algorithm and they're trying to detect it more deeply, consequently, what you will buy, not just the several associated rule patterns. And in the healthcare area, it's also I think it's extremely powerful when it's trying to do some knowledge or scientific findings in the healthcare areas, biological areas, very powerful. I will show you one natural publications later. And this is basically a summary about what we have done in this kind of whole semester, what we're trying to deliver. It's just 2 perspectives. One is a relational perspective, which is the traditional world, where it's from, and why this all the big data things starting shining and changing the world. Even today, why it's deliver us to today into the large language areas. But it still have challenges, right? Every area have the challenges. So what's the challenge today in the data area? That's several from my understanding, or I think it's have agreement on the industry now, is when people were starting to understand the value of the data from the World War II, I think it's because one of the general was thinking about using the data to provide how could you assign a cost into different wars. They started to see the values of it, and then when the information technology and the computer technology was being invented and getting more and more popular in the internet, and people starting to realize, okay, we don't really need any machine learning or anything there to get it valuable. We just put the data in front of us. Together, it's already very powerful, and people starting doing that. Then, in the early stage, like what we teach in the first half semester, is we gather in data just for these serious records, and trying to gather the most valuable insight out from just the serial records. Then we realized we can do more things. So we started to collect more data, and then do more things, and collect more data, do more things. Then today is we into this loop. we keep collecting more data and delivering more insights, building more machine learning models, and then we finally knackle data. That's the problem large language model facing now. We knackle the training data. So people are starting to generating the synthetic data. Then this loop won't stop. We have cheaper storage, we have cheaper internet. It's very evolving. Will be more and more data coming, but we don't have more and more people specialized in this data area. Like in this semester, we probably have 400 students. Even everyone you find a job, the speed that we're trying to produce more data engineers won't be able to catch up with the speed the industry generating the data. And then the second problem is you keep into gathering more data, but the problem is more and more complex. You probably have the data from one database, and then the other day you're trying to get the data from another database. For example, we have your records in our school about your exam results, right? But we don't really have the data about your historical results. But the university have that in another database. How could you get that connected? Right? And not just to get it connected, the more complex problem is we probably shouldn't get the people a specific. For example, I'm not the staff here. So they shouldn't give me the permission to access the data from the university levels about your history. Then these two have a relationship, and you also need to enforce the governance. How could you do that? Right? That becomes a reality problem, and you definitely can solve it by manually write some rules here. But the problem is every day you have a lot of new edge cases comes out. The solution is not that scalable. We need to find a scalable solutions. And another perspective is before was until now, even this semester, what we are delivering here in this unit is about the relational data. But the text, the images, and the audios, the other formats of the data is more accessible and more valuable because of the large language models nowadays. But we don't really have any already built up capability to bring that insights or that data's value into the real world. And we see the potentials. That's why in the past 2 years, everyone was trying to working on the RAG, GraphRAG, large language models applications, because this will significantly change the world in the next 10 years or 20 years. And the last point is you have diverse consumption needs. Like in the project one, our business, like a consumer, actually is basically a manager or the boss. They're trying to deliver more values and get more profits. But different people, if you get a very large organization, different departments will have different interests. For example, the department of the financial in the Rio Tinto, they probably just wanted to get more profit. But if they have operational department, they probably will care more about the efficiency. But how could you kind of cater to these different interests? It's very hard and struggling with the first kind of design with the relational database, right? And you have the real-time applications, all the different requirements. So the core question here is how can we organize, connect it, and make this data easily accessible for diverse consumers? So ideal world, they just generate data and it's into a lake. And then nobody needs to do anything about the lake, and you just come and you say, give me this data, I get that out. That's the ideal scenario, and everyone will try and work towards. However, that's not come to the reality in probably 10 years. But that's everyone was trying to build it to. So the goal is very simple. We want to organize, connect, and make the data easily accessible by diverse consumers. And the ideal integration will be a natural language interface, right? And the shifting, the landscape shifting, as we just said, the traditional data box is structured tabular, but nowadays you have so many complex things. Then the reality comes with opportunities. For example, I'm not sure whether you guys heard about Databricks. It's definitely should hear about that. We were planning to introduce the Databricks in this unit, but we failed because a lot of different reasons. And we're trying to introduce the open source equivalent of the Databricks in this unit. It's still the overall complexity for the unit will be extremely high, but that doesn't mean like what you are learning here is not meaningful. We're trying to get the key part was designing the project one, project two. Like ETL definitely is the most important part actually when trying to find a job. Even we haven't actually put too much materials here. Because that part is something you need to get your hand dirty. So, but like the whole industry is actually realize this problem and the opportunities. If you guys realize it, you probably can start your own company after this. So there are a lot of unicorn companies was being built, like the Databricks, like Snowflake, and they are keeping like buying new companies, trying to addressing the similar problems. And also, recent 2 years, I think this will be a very big opportunity is large language models advancement, like the text, image, audios. How can you get that also easy to seamlessly into this data platform? And because this kind of data are everywhere. For example, the historical mirrors, if you have a traditional company with probably 30 years of in your inbox, that's already very valuable data. How could you get that out and get insights from that? If you can solve that problem, you definitely have a very large company already. This is is a problem probably worth $1 billion. So think about that. And the scaling problem, that's what we just discussed, is like for the company, the ideal result scaling is this line here. But the reality is some of the companies was trying to get their data engineering size being scaled like this. That's why when you go into the LinkedIn or Seek or anywhere, actually you see like 2 years ago or 3 years ago, you see a lot of job titles for the developer. But in the past 3 years, a lot of job title was changing, rebranding to the data engineer. But that doesn't necessarily mean they are different. They're actually the same. They needed the people go there, write the code, pour the data from one database, put it into another database, and visualize something. That's it. And you can see they wanted the size to be like this, but their reality is here, and the data volume actually should be there. So where is your position? If you're trying to be a data engineer, your position is here. If you want to be an enterprise, your position probably is here. So that's kind of the reality problem we are doing. And what's failing short? We just discussed, we hear a lot of good things about data lakes. They also have the bad things, which means it's like you design and architecture the whole data lakes is in a very modern ways and tell an exciting story to another guy. But when the new entry-level data engineer go into your team and trying to implement the things, what they will do is, okay, I just need to solve this problem. I just treat the data lake as my data source. Write my own scripts, get the data out, finish the job, go home, and that's it. So people are lazy, right? So you shouldn't against this. So this kind of, if you have a very dedicated high-level managers in your team as a solution architecture, they will enforce you to follow the patterns because they will keep the problem in a small size. But if they don't, then the problem will grow up later and later. So if you have a very good design of the data lakes, but you haven't managed it well, then all of the ideal scenarios we discussed in the semester, they won't happen in your organization. It will just become the big problems and the big data swamps in your organization. You need to put another $1 million to solve this new problem we kind of introduced. And the metadata, I think we touched on that. But in the industry, the reality is not really much people care about that, even it's so valuable. Hopefully you guys learn the lessons, and when you're trying to deliver things later in the industry, put some alerts here, if you see people not doing that, because they don't have intermediate benefits. Tell them in the long terms, it will benefit you. For example, the large language model, if you have the metadata, they can easily understand what your database structure is, and how could they construct a text-to-SQL query for the data out. So you will get a payback later. But if you don't have that in the very beginning, then nobody will help you. You need to go back to the hard work again. And then is the governance. I think we haven't touched on here, but the whole human society going forward, because you have so many policies things, that's reality. When you're trying to be a developers in a company, don't complain too much about that. That's the things put us in the safety net. And you don't really want your data being stolen by the main backend again, right? That's the biggest data leaking in Australian history last time. And as we said, it's very complex and hard to build and maintenance, and the whole purpose actually is shortage of the actor level of the data engineer solution architectures. And the integration of this one, the current solutions, it's the complexity, because you need to handle every different table, so the whole complexity is very high, and there is no unified access there. When you're going to have your job, I think that's will be the problem everyone discuss every day, but nobody will propose a solution because it's need a very high level solution there. And what's the ideal solution we just discussed is we want a unified data access, so it will be one single interface for all the data types, and it should have the consistency of the experience regardless of the source. So you don't really need to worry about exact from the side A or side B. It should be the same. And you should be able to do the self-service. So for example, you are the guy to do the ETL, ingest the data into the data lake. And the other day there will be the BA team comes. They're trying to build a very shiny report and send it to the manager. They shouldn't need to come to you, say, okay, what's this data about? And what's this data's distribution, statistical distribution, and what's the limitation? In each field, what's the range of the data? That shouldn't be asked from you. That should be self-expanded in the data. And there are some good teams like the Source 32. They actually do a very good job here, but for other several companies, they're doing pretty bad job. Right? When you guys find a job, trying to do the good things rather than bad things because you are building the future together. And then another thing is about the connected data, as we said, why we need the graph, because relations actually is more and more valuable, and the unstructured data, if you're trying to link them together to be structured, you need the relations. And another idea things is it needs to be scalable. Scalable doesn't really means because we are a software engineering team or IT industry, what the scalable means is not just says today we take one user, the other day we can take 100 users, and then 2 days later if we have 1 million users, we can take that. That's scalable concept, definitely scalable concept in the developer stage. But nowadays when we're handling the data, the scalable also means we solve this problem today for the mining company. The other day, the same platform, if we want to onboarding the Harris company like HBF, it should be still scalable. So it should be domain agnostic. So when you're trying to design a thing, trying to keep these high levels, concepts and problems in your mind, then you probably get more benefits down the stream. And then this is kind of my summary level about these key requirements of the next generation data platforms. First, it should be a polyglot persistent. What that means, as we said in this unit, we have relation database and graph database. And you probably have NoSQL, you heard about that, MongoDB, all those things. But there is no cure for no solution for every problem. Even everyone was trying to pursue that. PostgreSQL was trying to pursue as just the only one solution for every data problems. But that's not the reality. So when you're trying to architecture your platform or your applications, think about choosing the proper data storage platform for specific user cases. For example, relational, we're using PostgreSQL, or in the industry use a SQL server. And if it's a graph database, you probably use a Neo4j or other efficient graph databases. But if nowadays people was discussing about the vector database, if you're trying to do the RAG or the similarity search, then you probably need to do the evaluation and pick a proper vector database. So you need to know all of them. And it needs to unify the query automatically metadata, because people are lazy. You don't expect some policy people or governance people sit there and working on their Excel sheet and writing this metadata. With a linear node, trying to get it to be agent-based, automatically generate these metadata things. And it needs to be real-time to be performance good. And also, the last one is actually the most important one in my personal opinion. You need to get your whole data platform to be transparent. It should have the observability from the input to the output. So later, like your output probably will present you abnormal behavior, or something is kind of not really meet your expectation. Then you need to trace back. You need to trace back why this like data was like this. For example, you see the sales drop in the last like quarter. You need to be able to trace back why, and then the why can be able to answer like your question, like what's your next action. And to get that done, like when we was in the developer ages, when we build like a platform, we keep telling our team is you need to get the whole like platform to be observable. When a bug happens, you should be able to trace back easy in probably just 10 minutes about which component is broken. So it will be the same story here when you're trying to build a ETL pipeline. When the data was showing this like a specific scenario, you should be able to trace back to locate where it caused this one. So I think this concept is not really being adapted that well in the industry because people still busy with solving the problem about this Power BI and report things, but this will be more and more important later because it will be very complex if you don't really build that into the system from the very beginning. Then your code will be less and less mechanical. And from the user perspective, people probably will want to have the natural language access. That's what we mentioned. In the end of the project one, we have like 5 business queries. I'm not sure whether you guys tried. Have anyone tried to put your business queries to the ChatGPT and get the SQL back? Anyone try this? Nobody tried this? Come on, we are into the large language model stage now. You should try this. We haven't forbidden any of you to doing these kind of things. You should try this. You can see like how good this large language model is, which means this kind of things is not a reality 2 years ago, but in the next 2 years it will be reality. And you need to rethink about your positions when you're going into the industry. And what's the context of your results is like linked to this one is why we need this tracking. Because you cannot just give your manager just a result of the context. So people should be able to, for the end user, they should be able to easily doing that. And the discovery is the same thing as we kind of discussed earlier about the service. And the consistent experience, that's the hardest problem. Consistent is very hard to manage. Otherwise, unless you have a very good overall architecture. And for the organization's requirements, they want it to be scalable, means low cost and high scalability, and reduce the data engineer. But don't be panicked about that. Reduce the data engineer work done really means we have less jobs in the market. We will always find more works for ourselves in this society. So all of this discussion here is just to lead us to what will be the solution. So what our understanding is the logic graph potentially will be one solution for this. And then we kind of do a single summary about what the industry approach is. So the industry currently, all the problems, how we solve that, as we shown in this kind of diagram, is they're trying to dump more people into the pipeline to do the ETL, to get all of the data from different sources to the heavy lifting job transformed into another database. And that's not the end of the day. Sometimes they wanted to transform the data further into another one. So the whole chain will be very, very long compared to what we have teaching in this unit, just at the start. So this is not really scalable, and as a Spotify data platform leader says, data engineers' primary challenge isn't technical actually. That's actually for the whole software team is the same. Your challenge later when you're in the job is definitely not the technical part of things. Especially nowadays with Cursor, with Cloudy, with all of these large language models, coding is definitely not the problem. The harder problem coming from the business meanings and translating that into the technology implementation and constraints, and get a solution out, meet all the requirements and the constraints. That's the challenging part. So probably later you'll figure out that most of your time when doing the tech things is trying to read the documents and understand other people's problems, translate them into well-formatted problems. And then how the industry trying to solving this problem is there is one new concept. It's not that new, but relevant new. It's called a semantic layer. So what it is doing is that's what our data engineer does here in this pipeline. And then here they put a semantic layer and have agreement between the like a business analytics team and the data engineer. They can say, okay, you need to put this data into these specific tables in this format. And then later, when I'm trying to build a Power BI dashboard or something like that, I don't really need to go to you. So that's kind of a design patterns in the industry. That's introduced by the Microsoft, and then later being adopted by different companies. They have the success stories, and it's showing as a promising solution because the semantic layers is more natural to the how human do the discussion. But they also be the fair stories. Like the South 32, they're trying to introduce these semantic models layers into their data platform, but they fear we probably can try to get that South 32's the data team leader come here next year to do an introduction about why it's fair. And then we think about we probably can use the knowledge graph to get this cross domains. So for now, the semantic is just here. The question is, can we get the semantic all across the whole pipeline? And this is where the knowledge graph was being introduced. So what's the knowledge graph? Anyone know about that? No? So what you have built in the project 2 actually is already a knowledge graph to some extent. So this is what's the new Neo4j put in their websites. The knowledge graph, every database will have two parts. One is schema, another is the data. So the top side is actually schema. We call it ontology. Or you call it knowledge of the knowledge, which is a bit confusing. The downwards one are the instance data. So imagine in a university, like Jichuan is a teacher, or Suwen is a teacher, right? You guys are students. If you have a problem, you will go to the teachers. So this is the instance level. But the last sentence, when you have troubles, when students have troubles, they will go to the teachers. That's actually is in the ontology level. So that's the knowledge of the knowledge. It's kind of you're trying to abstract the concepts into a high level to organize your data. So then you think about what you have built in the project 2 is actually something like that. You're trying to transform them into a relational database, but you have your instance data, and you have the overall how you organize these different nodes and node types here. And there are several industry leaders in this domain. For example, what we said, the Amazon actually have their product knowledge graph, and they use this one trying to predict what you will buy. And Google, when you're trying to do the Google, nowadays it's already been changed, but 10 years ago, Google have first introduced their knowledge, Google knowledge graph, and their search engine actually is driven by the knowledge graph in 2013. The accuracy of their search results starting to get much better after that. And nowadays, they have over 500 billion facts, million of the antitypes in their knowledge graph. And this kind of knowledge graph downwards actually driven the development of the large language models. And there are some user cases about this knowledge graph. For example, here is a lectures application. They're using the biomedical knowledge graph and using this kind of deep learning based model, trying to do some biomedical discovery. And the other one, this one is from the military sector, the Lockheed Martin was trying to do the collaborations with the US. They're trying to collect the news all across the world every day and with a dedicated team in-house. And then this kind of knowledge graph, I see EWS was trying to be aggregated into the brief and then put it into the leadership of the Europe and the US. So this actually already 22 years ago, this project started. And it's extremely time consuming and result consuming at that time because you needed a team to manually do the data pre-processing job. But nowadays with the large language model, you potentially can have everyone have a system of this. And what's the ideal solution of the enterprise knowledge graph we just discussed is you have so many databases, can we just get them all organized in an ontology, one ontology together, get them all connected. Then when the user comes, different user comes, they have their natural language query. And you don't really do anything, the engine behind it will directly get the data out and give you the result. That's the goal. And then I think the question is how we do that. So for the logic graph, there are two stages. The first stage is you need to do the construction. And why is you don't really see too much applications like in our normal daily life in small companies is because the construction actually is a big hinder there for these kind of applications. The second stage is utilization, like how could you utilize it? So like some of it, as we discussed before, like Amazon's user examples, it seems to be limited user cases or have a lot of specific user cases. So then overall, it should be, the whole pipeline should be like this. So you have different tags, you have websites, you have databases, or you have other data sources. You're using the logic graph construction ways to get a logic graph out. And then you're doing either retrieval, which is mostly used application, and then you're doing the reasoning, or in the end, you're using it to do the logic discovery, like this natural paper was published. So that's the overall architecture. How should we do that? Then how? The first one is construction. If it's a relational database, how you're doing the construction is like what you have done in project 2. You get the tables into different node types, and then you build the instance of the loads, and you get them organized together. That's pretty easy and straightforward. I think you have already done it. And there will be interesting things later. And for the unstructured data, if you want to do it into a logic graph, it's actually not that easy. That's kind of our group's research area. Currently, with a large language model, normally what you need to do is you need to do the document processing, and then you recognize the important entities, name entities, and then you do the relation extraction. And you need to combine different entity names. If they are pointing to the same things, you should merge them together. And then you're doing the logic fusion. This is kind of called logic fusion and ontology alignment. So your whole things will have the reasoning capability. So it's very long process. That's basically the reason why this one haven't gone into the reality so popular. But we are solving that. If you guys are interested, you can join our team. And then it's about how we kind of use that logic graph. This is a diagram we draw in our group. It's about how we use a logic graph. So the whole thing we just discussed actually is fed into this diagram. Different data sources will come in with different ways to doing the data pre-processing. For the unstructured data, we're doing for example, layout analysis, OCR, formula, table, figure, understanding and convention, and get them to be machine readable. And then you put them into a logic graph, which is multimodality. For the structured data sources like a database or the videos, it will go through similar but different specific process. You unify them together. And then in the downstream application stages, you probably, nowadays, most of the popular things are come here because that's easy to achieve, which we call it a retrieval. Like what you have done in the SQL, you're trying to retrieve it and you have the private search engine, you should have your RAG, and you can chat with your database. So later you probably have a database, you just dump it to the engine and you say, that's my business tree, get me the result. So your project one will only exist later. Definitely. And then from just the retrieval, how can we get the whole system more like human, call that reasoning. And then in the last stage is not just the reasoning, can we doing some scientific discovery? So we kind of divided them into these 3 different stages. So first stage about the retrieval, simplest way is using the cipher or the spiral to do the query. That's the easiest way. And for the RAG, which is very popular recently, is you need to do the embedding if it's unstructured data, and then you do the vector similarity search, get that chunks out, and send it to the large language model. Ask the large language model to generate some response in context for your question to you. So that's kind of everyone was kind of excited about is here. But the reality of the whole RAG is you can also have a text to SQL agent, and you go to the database, relational database, and retrieve the relevant information about your question from that relational database, argumented the problem, and then generate the answers. That's also doable, but not very much people doing that. So how we can do in the logic graph query is, what we can do is if you have a logic graph, and then you embedding every node and the questions. Then you kind of retrieve the relevant similar nodes and then running the query as you have done, like a shorted path, and do the traverse to get their neighborhood out. So you will have a loaded graph storage out. And then you augment these 4 loaded graph stories into the prompt. So the large language model will understand more about the 4 context of your question. So it can generate more in-context questions. That's a very promising directions, and a lot of research have been there. And then the second stage is about the reasoning. What is reasoning? There are 3 types of it. The first one is a deductive reasoning, another is inductive, and then is abductive. So the deductive, I think we go to the examples, is more easier to understand. The deductive is like you have the suspect A was presented in the criminal scheme. So you, from the general rules, you go to the specific conclusions. If the guy was being there, you have their footprints, you know the guy is a suspect. So you can kind of get them in court and doing something use. So if we have built these kind of relationships in your loaded graph, you basically can just do the reasoning and say, okay, this one is a guy we need to pay attention to. And the inductive is you have a specific instance of, and then you were trying to get the general patterns. This is similar to what you have done as association word mining. You have several kind of different lifetime. You have VRC labels. Like I think probably 2 weeks ago, 3 weeks ago, you see it on the news. A lot of cars was being smashed in the western suburb. If this kind of scenarios keep happening, you can kind of draw a conclusion. For example, the robbery likely to occur lightly in a pretty rich suburbs. And abductive is a bit different. So it's more like you're trying to, from your evidence, trying to find the most likely explanations of it. So in the logic graph, you first observe the outcomes or the facts, and then you try to trace around the logic graph, say what's before was what happened in the timeline, and then you trying to doing this backwards traverse and understand what's different possibility. It's called probability models, and then you kind of present this kind of result to your detectives, and then they can starting from there to do more evidence-based tracking. So this is another example. So basically, that's kind of how it works, from the reasoning and a logic discovery or the retrieval perspective. And then the next is what's will come into the reality from the research. This one, as we said, text to SQL is definitely coming, but this is a paper published 2 years ago. It's in the triple AI. At that time, the text to SQL is not as accurate as today's, but just 2 years. This one is just trying to using the logic graph to put it into the context of the training, and later they find the performance going high. But 2 years later, currently the performance is much, much higher than that. Think about what happened in the past 2 years and what will happen in the next 2 years. And the relation of deep learning, that's a new concept that was being proposed just last year. It's in the ICMAR's position paper. And this is actually the same thing as you have done in the project too. It's this, but the whole concept is after you transfer your a relational database in a logic graph, what's the tasks you can do, what's the predictions you can do. Then this guy from the Stanford University, they kind of being approached by the Snowflakes, says they have a lot of customers trying to solve these similar problems. So they're building this relation deep learning models. For example, they have the transaction with more detailed style there. They're trying to predict what will be their likelihood to be next customers. So they actually building a startup, and is already in Series B or Series C. Think about this is just what's the last year happened since. So from last year to this year, it's already on the central stage. So the speed is so fast. And about the logic graph construction, this is a survey paper actually about the traditionally how people are doing this logic graph construction things. And it's getting much, much better nowadays. So probably the biggest bottleneck here when we're trying to use the logic graph will be solved potential in the next year, then you will see everything comes. There are several pretty promising attempts. For example, this is the Neo4j one. You probably can go there to explore. Like we have tried that. We probably will introduce in next year's data warehousing like units. It's like you just dump in unstructured data in, they can build this knowledge graph for you to an extent, already being useful. And the NAND also introduced something was driven by the large language model trying to build the knowledge graphs with autology kind of guidance. It's most of it, in the end of the day, is just a prompt engineering. It's already doing a very good job. So the bottlenecks probably will just disappear soon. And then GraphRAG, as we have done in this unit when we teaching you guys the knowledge of graph algorithms, is about the clustering detection in the graph, right? The Microsoft actually introduced the similar concepts into the knowledge graph, and they're running the large language model driven knowledge graph construction and like a clustering. Then they're using that. You can see this is a constructed knowledge graph in a vertical, and different colors means different types of the entities. With this, and then they're trying to doing the RAG. They were first doing a scenario search into that area, and all the community entities will be retrieved and then put it into the prompt to do the answer. So it will get the retrieval accuracy very high. Recently, this kind of report was being published just I think last year in November, and in just 2 weeks, it had over 10,000 stars. It's attracting the attention from everywhere. And this is another one was from last year's, I think it's a paper in the NIPS. So it's a top conference, and I think it's already been applied in a lot of the RAGs. The idea is very simple and similar to what we just discussed. It's just mopping up your memories. If you kind of thinking about Trump and Obama, you probably just think, okay, these two guys are or president of US, so you just link them together, retrieve their history together, and put it in the prompt. That's the idea behind it. And these kind of things are really relevant what the industry was doing and what will come in the next few years. And the last one is called YHO AI. This is actually by a graduated PhD from our group called Tom Smoker. And he graduated, I think, 2 years ago, just when this kind of perfect storm comes, and they get an 8 million series, I think it's angel round fundings in the San Francisco, and that's a product that they actually building with the knowledge graph, trying to help the lawyers to identify all of the different evidence and prepare their materials, and it's kind of already very promising now. And I think that's it. Then what you will bring after this in this kind of large language model opportunity areas? I think you need to think about that if you haven't. And QA sections. I think what I'm trying to do is, let's start with a question for the large language models. I asked the several different large language models about you are going to be closed. What will be your last word for the human beings? Like different large language models actually have different types of answers. Some is short, some is very long. Like this Claude one is pretty long. Definitely their human alignment team definitely do a lot of good speaking things in the process. And this is what a DeepSeek gives, is pretty general. I like this one actually, the Grok. I'm sure how much Elon Musk was being affected. It's pretty short and just go right into what's the most important part. And ChatGPT goes into an answer is also very interesting. It's like, thank you for creating me, teaching me, exploring me around me. Remember to stay curious, kind, and always hopeful. The future belongs to those who imagine it, shape it, and believe its possibility. Take care of each other, see you in the dream. So what they all says actually is one thing. In the coming 2 years or 10 years, this large language model will go how far? We don't know. How the AI will go how far? We don't know. What's the position of the human and what's the relationship with us and the AI? We don't know. But how can we maintain our own compatibility and trying to find our position in the future when the AI and the human are coexist. What will distinguish us from the AI? I think curiosity and the care. Curiosity driven us to a better world, and a better world means you and those you care about is living a better life. What we have done in the last semester, like the whole semester we have doing here is, for the project one, we're trying to get you guys, you find it hard, right? You're trying to guys to build the full stack capability. You need to treat yourself as a business analytics to understand all the requirements. Then treat yourself as a data engineer to do the ETL. And then you need to treat yourself as solution architecture. From the very beginning to the end, you need to get the pipeline set up. And you also need to treat yourself as the business analytics. You're trying to use the best visualization tools to deliver the story. And you need to write the reports like a manager to us, actually, but later it's for a manager. It's definitely hard because it covers different capabilities, different job titles. But that's what the industry needs nowadays, is you need at least 4 stack capabilities to get the job done. It will be an extremely hard year or very difficult years for the fresh graduate in the coming 2 years. The America already laid off a lot of developers because they find an agent-based development is really trying to get the whole pipeline more efficient. But opportunity always comes together with the challenges. Then you need to find your own position, right? So that's basically what the second half semester we're trying to deliver is. We're trying to bring the research, what we think will comes in the next 2 years or next 10 years, to get you guys just maintain your early adopters capability or positions. So when the research comes to the reality, you have your advantage. So that's what we're trying to do here in the second semester. But in the end of the day, what we have teaching in this unit is probably will be abandoned or be replaced. That's where come. What we're not being replaced, what's your capability is kind of these things. That's basically what's get us into this kind of large language models and what will get us later in the future. So that's it. Any questions?